Right now, as you sit comfortably listening to this voice, directly above your head at an altitude of a few hundred miles, a giant cloud of high-speed metal debris is orbiting our planet at mind-boggling speeds. We are not talking about asteroid dust or natural space rocks. We are talking about human garbage. Old dead satellites, spent rocket boosters, frozen paint flecks, dropped astronaut tools, and millions of sharp metal shrapnel pieces are circling Earth like a dense, lethal cloud of cosmic bullets. Since 1957, when humanity launched Sputnik 1 into the sky, we have sent over 15,000 satellites into space. For decades, space agencies treat low Earth orbit like a giant, endless ocean dump. When a satellite battery died or a rocket ran out of fuel, engineers simply walked away, leaving heavy metal hulks floating in space forever. Today, Earth's near-space environment is so outrageously cluttered that space tracking networks monitor over 36,000 pieces of space junk larger than a tennis ball, and an estimated 130 million tiny fragments smaller than a single millimeter. Welcome back to Cosmic Clueless. Today, we are putting on our high-tech suit, firing up our orbital thrusters, and launching our unluckiest Stickman proxy into the cosmic dumpster above Earth to ask a terrifying question. What happens when our orbital garbage creates a chain reaction explosion that traps humanity on Earth forever? Before our Stickman starts cleaning up the sky with a broom, he needs to understand the brutal, terrifying physics of orbital velocity. In space, there is no atmospheric air resistance to slow objects down. To stay in low Earth orbit without crashing back into the ground, everything from the giant International Space Station to a tiny lost washer bolt must travel at a blistering speed of 17,500 miles per hour. That is roughly 23 times the speed of sound, or nearly 10 times faster than a high-powered rifle bullet. At those insane speeds, kinetic energy behaves in completely horrifying ways. A tiny half-inch chip of dried paint fleck hitting a space station window at 17,000 miles per hour delivers the kinetic impact of a heavy bowling ball slammed into glass at 100 miles per hour. A floating metallic bolt becomes a high-explosive grenade, capable of punching a clean hole through solid aluminum satellite shielding and destroying a $100 million spacecraft in a microsecond. Picture our Stickman proxy floating outside his space shuttle in his bulky white astronaut suit, proudly holding a high-tech orbital garbage bag. He spots a tiny, innocent-looking silver screw floating gracefully toward him through the black void. "Oh, look, a cute little space screw," he thinks, reaching out his gloved hand to catch it. But because the screw is moving in a counter-orbit at 17,000 miles per hour, it hits his Stickman hand with the force of a tank shell. The microscopic bolt obliterates his suit glove, spins our Stickman like a helicopter rotor blade at 3,000 revolutions per minute, and launches him backward straight through the solar panel of his own shuttle. He emerges tangled in solar wires, his space helmet glass cracked, while alarm sirens blare through his suit headset. Classic Stickman spacewalk maneuver. Once our Stickman untangles himself from the solar panels, we have to look at how all this junk actually got up there in the first place. While dead satellites naturally decay over decades, the vast majority of lethal space shrapnel was created by a few catastrophic orbital events. The first major cause is exploding rocket upper stages. For years, rocket boosters left in orbit still contained leftover, unvented hypergolic propellant and pressurized batteries. Over time, harsh solar radiation cooked these dead boosters, causing the fuel tanks to rupture and explode, turning a single rocket shell into thousands of deadly, hypervelocity bullets. The second major cause is intentional anti-satellite missile tests. In 2007, an Earth-based missile slammed directly into a dead weather satellite, creating the single worst orbital debris cloud in human history. Over 3,000 massive tracked fragments and hundreds of thousands of untracked pieces that will orbit Earth for centuries. And then came 2009, the year space had its first major head-on car accident. An active commercial iridium communications satellite, collided directly with a dead 3,000-pound Russian military satellite over Siberia at 26,000 miles per hour. The instant impact vaporized both spacecraft, blasting over 2,000 large metal fragments into space like a cosmic shotgun blast. What happens when these explosions keep hitting each other over and over again? Let us move on to part 2 and examine the nightmarish domino effect that could end space exploration forever. The Kessler Syndrome. In 1978, NASA scientist Donald J. Kessler proposed a terrifying mathematical scenario that haunts every space agency on the planet today: the Kessler Syndrome. Kessler realized that as the density of space debris in low Earth orbit increases, the probability of accidental collisions grows exponentially. But here is the nightmare catch. Every single collision between two satellites doesn't just destroy them. It creates thousands of new, high-speed shrapnel pieces. Those thousands of new metal fragments then float out like a giant cloud of cosmic buckshot, striking other neighboring satellites, which in turn explode into millions of even smaller pieces. Once the density of orbital garbage reaches a critical tipping point, a single catastrophic collision can trigger a runaway, unstoppable chain reaction of orbital destruction. Within weeks or months, every active satellite orbiting Earth, GPS networks, weather predictors, military communications, banking infrastructure, and internet constellations would be completely shredded into glowing metal dust. Even worse, the entire near-Earth space environment would become an impenetrable, lethal wall of high-velocity metal shrapnel moving at 17,000 miles per hour. Humanity would be completely trapped on Earth for generations, unable to launch rockets, explore Mars, build moon bases, or send astronauts into space without them getting instantly vaporized. Naturally, our Stickman proxy decides to test out the Kessler Syndrome chain reaction firsthand. He floats outside a high-tech orbital lab with a tiny, innocent-looking metallic spanner wrench. He accidentally drops the wrench from his greasy Stickman fingers. The wrench drifts into the path of a dead solar panel, snapping a tiny piece of metal loose. That tiny metal piece slams directly into a fuel tank on an old satellite, causing a massive hypervelocity explosion. The explosion shoots 200 sharp steel fragments straight into a nearby constellation of internet satellites, turning them into a cloud of glowing razor blades. Within seconds, the domino effect arcs across the entire night sky. Our Stickman watches in utter horror as a massive cloud of high-speed junk shreds his escape shuttle into confetti, leaving him floating in his underwear, holding nothing but a broken steering wheel. Classic Stickman chain reaction. While the full Kessler Syndrome hasn't completely sealed our atmosphere yet, the threat is so real that the International Space Station has to perform automated debris avoidance maneuvers multiple times every single year. If a piece of tracked space junk is predicted to pass within a few miles of the station, mission controllers fire the ISS thrusters to nudge the multi-billion-dollar laboratory out of harm's way. But when an untracked piece of debris sneaks up without warning, astronauts don't have time to move the station. They have to rush inside their docked Soyuz or Crew Dragon escape capsules, seal the emergency airlocks, and sit in total darkness with their pressure suit helmets locked, praying that a microscopic bolt doesn't punch through the station's living quarters. So, how do we fix a multi-billion-dollar garbage dump floating in the vacuum of space? You can't just send a crew of astronauts up there with giant plastic trash bags and brooms. Engineers around the world are currently designing wild sci-fi solutions to clean up low Earth orbit. Option number 1. Orbital nets and harpoons. Mission satellites like Europe's Remove Debris test launching massive Kevlar nets over dead, tumbling satellites, wrapping them up like fish and firing heavy titanium harpoons directly into their aluminum bodies to drag them down into Earth's atmosphere to burn up safely. Option number 2. High-power ground lasers. Scientists are testing giant ground-based laser arrays that focus high-energy light beams on approaching space junk. The laser doesn't blow the debris up. It slightly vaporizes a microscopic layer of the metal's surface, creating a tiny plasma jet that acts like a brake, slowing the junk down just enough so that Earth's gravity pulls it into the atmosphere. Our Stickman, now wearing an improvised firefighter hat in space, gets put in charge of operating the experimental orbital harpoon cannon. He aims his giant titanium harpoon at a dead 3-ton rocket stage tumbling through orbit. He pulls the trigger. "Fire in the hole!" The harpoon shoots out on a thick steel cable and slams into the rocket shell with incredible force. But the rocket is spinning at 40 revolutions per minute. Instead of dragging the rocket down, the cable instantly wraps around the spinning booster, reeling our Stickman's tiny cleanup vessel straight into the spinning blades of death. His ship gets spun like a wild carnival ride, flinging our Stickman out through the windshield and wrapping him up tightly in his own cleanup net like a cosmic mummy. Will humanity ever manage to clean up the sky before the orbital trap snaps shut forever? When we successfully drag dead satellites and rocket boosters out of orbit, where do they actually go? Small pieces of debris burn up completely in the upper atmosphere, turning into harmless, glowing shooting stars due to the extreme atmospheric friction that generates heat over 3,000 degrees Fahrenheit. But giant multi-ton spacecraft like dead space stations, heavy scientific observatories, and massive rocket stages are way too large to melt away entirely. Heavy titanium fuel tanks and dense structural frames survive the fiery plunge and slam straight toward the surface of Earth. To prevent these falling space monsters from crashing into populated cities, space agencies use controlled re-entry burns to target the most remote, desolate location on planet Earth. Point Nemo. Known officially as the oceanic pole of inaccessibility, Point Nemo is a spot in the South Pacific Ocean located over 1,400 miles away from the nearest piece of dry land in every direction. It is so isolated from human civilization that the closest living people to Point Nemo are often the astronauts floating on the International Space Station when it passes directly overhead. Deep beneath these freezing ocean waters lies the Oceanic Spacecraft Cemetery. Over 260 dead spacecraft, including the legendary Russian Mir space station, dozens of automated cargo ships, and soon the massive International Space Station itself in 2031, rest silently on the dark ocean floor, 4 miles beneath the waves. Naturally, our Stickman proxy, still wrapped up like a mummy in his own orbital cleanup net, begins falling out of orbit, plummeting straight toward Earth at Mach 25. His net turns into a fiery ball of glowing plasma as atmospheric friction melts the synthetic cables. He breaks free from the net, screaming at the top of his lungs, his Stickman cheeks flapping wildly in the supersonic wind. He plummets straight down through the dark clouds, aiming directly for the freezing waters of Point Nemo. He deploys his emergency parachute at the last second, landing with a loud splash right in the middle of the empty ocean. "Hooray! I survived the fiery space crash!" he shouts, floating on his back in his life vest, waving at the empty horizon. But just as he catches his breath, a giant 3-ton dead satellite falling out of orbit plunges through the clouds directly above him, landing right on top of his head with a massive ocean splash that blasts our Stickman straight down to the bottom of the ocean cemetery. Classic Stickman luck. In the end, solving the space junk crisis is not just a scientific challenge, it is a mandatory requirement for the future of human civilization. Modern international treaties now mandate that all new satellites must carry enough reserve fuel to deorbit themselves at the end of their operational lifespans, or move into high-altitude graveyard orbits far above commercial satellites. Companies are testing laser propulsion, magnetic sails, robotic grapple arms, and autonomous cleanup drones that will systematically sweep low Earth orbit over the coming decades. If we succeed, space will remain open, safe, and ready for humanity's march toward Mars and the stars beyond. But if we ignore the growing cloud of high-speed shrapnel above our heads, the sky above us will turn into a permanent ironclad cage, trapping us on our home planet forever. What do you think is the best way to clean up space junk? High-power ground lasers, robotic harpoons, or sending stickmen up there with giant brooms? Drop your wildest cleanup ideas in the comments below. If you enjoyed this journey through orbital disasters, the Kessler Syndrome, and Stickman satellite crashes, smash that like button, subscribe to Cosmic Clueless, and hit the notification bell. Watch out for falling screws, keep your orbit clean, and we will see you in the next episode.